Hello and welcome to this, the first of 3 video lectures about the human value of science. It is called Problems and explores the question, what role for science today? What is science? Here are some definitions with the underlining done by the author. From Google, the systematic study of the physical and natural world. From dictionary.com, a body of facts or truths systematically arranged, deriving general laws. From Collins Dictionary, the nature and behavior of natural things and the knowledge that we obtain about them. So putting that together, it's about systematic study, which brings us facts or truths, and from that we have knowledge. We acquire knowledge. And in the popular mind, science includes innovation and technology. So when we're talking about science, we include innovation and technology, at least in this lecture. It's all about what works and what can work better. Maybe science should be the core human value, not liberty. After all, human ages are defined by metallurgy, which is a science. We had the Stone Age, which was when no metal was being used, Bronze Age, which was a particular type of metal being used, bronze, and then the Iron Age. Stages of human development are defined by technology. Hunter-gatherers used tools. Agricultural civilizations developed farming, buildings, transport. And industrial societies have myriad technologies. We could define the stages of human development through technology. Science and innovation and technology deliver increased social development. We make progress. Things like irrigation, navigation, steam engines, sanitation, electricity, and so on and so on and so on. Scientific study leads to knowledge, which is part of our social development that we call progress. Increased knowledge is, in of itself, usually a good thing. There are issues about how we use our acquired knowledge. Metallurgy is used to make high-quality swords. Chemistry gives us gunpowder, and physics has gifted us nuclear weapons. But put to practical purpose, knowledge also increases health and wealth too. Think about the implications of the scientific discovery of the blood circulation system on our health, or a steam engine linked to a pump, allowing mines to be dug deeper, thus enhancing wealth with the minerals that the mine produces. Science, innovation, and technology also deliver tolerance, reducing social segregation, with things like money, the printing press, laws, the internet, birth control, etc. A steam engine can be put on railway tracks, and you have a train that reduces the distance between people. That reduces social segregation by reducing the distance between people. We can see how social innovations like money and new technologies like birth control deliver social change that reduces social segregation. Money facilitates trade, which brings more people together. Birth control allows women control of reproduction, which brings more women out of the home and into wider society. The result of noticing or studying the positive effects of implementing an idea and technologies developed from hard science play a role in the expansion of liberty in society through tolerance as well as progress. The scientific method of systematic study can be applied to humans and their societies. The social sciences are also science. Hard facts or truths sometimes, more often softer tendencies. But all of that is knowledge about ourselves. Social science is the study of a specific part of the natural world, we humans. While the knowledge gained is not always as hard and fast as the facts that physical science mostly delivers, the softer knowledge of tendencies that we gain from the social sciences can be incredibly useful. Just some examples of how people who care for others can do a better job with knowledge. With children, for instance, how better we can teach children if we understand something about the cognitive processes of learning. The sick, how better they can be treated if we understand the relative importance of feedback and encouragement. Old people, how better we can try and enrich their lives if we understand the debilitating effect of loneliness. Additionally, through the hard science of genetics and the social sciences, we've discovered how alike we all are. When you scratch beneath the skin or skull, we see differences, but the same patterns and issues emerge. We are different as individuals, but pretty much the same as humans. Social science has done us the additional service of preparing us for more tolerance. So we have much to be grateful for when we think about science. But today, science has a problem. Actually, at least 3 problems. Problem number 1, science is not always accepted. The list here is not exhaustive or definitive, merely an indicator of the fact that science is not always accepted. As discussed in the 3rd video lecture on the human value of liberty called Feel and Think, we're programmed from birth with, and developed through life, traits, values, biases, and moral principles that are stored in our subconscious and retrieved as feelings. Once those feelings are formed in our conscious minds, we are motivated to reason in support or defense of those feelings. That affects how we view scientific research. Here are 3 notorious examples of how science can be rejected if it doesn't fit with motivated reasoning. Galileo's observations of a solar system with the sun at the center didn't fit with the church's dogma, which had the earth as the center of the universe. To many, Darwin's conclusions were and are unconscionable. Simply not something many people want to think about, to have in or on their conscience. Biology and psychology are ignored by today's advocates of a gender spectrum. Biologists and psychologists studying aspects of female or male behavior live in professional fear of being called out, to be accused of biological essentialism. If they are so accused, that will bring down the mob on them, and they are guilty of no more than taking their science seriously. And science is becoming more inaccessible, less understandable. After Einstein's relativity and quantum mechanics, 2 very different aspects of physics, science has become more and more narrowly defined in subdisciplines, and to those outside, less and less intelligible. It's not enough for a physicist or biologist to say, I'm a physicist or I'm a biologist. It means nothing to his colleagues unless they specify the exact field and who their supervisor is. Only then would someone in the know be able to engage in any kind of professional discussion with the scientist. For the rest of us non-scientists, even those with college degrees in STEM subjects, they've lost us already. We just cannot follow the conversation because these scientists have spent years narrowing their focus until it's so narrow they can claim expertise in that narrow domain. And the social sciences are not alone, think climate models, in relying on statistical analysis. There are lies, damned lies, and statistics, said Mark Twain and others. For some reason, even the numerate amongst us struggle with statistics. Try the Monty Hall problem if you've never had to struggle with statistics yourself. Some science depends on statistics, probabilities in quantum mechanics, and levels of uncertainty in climate models, to take 2 examples. And before we even try to understand what it is that a scientist is trying to explain with statistics, they're up against our dislike and fear of this voodoo science. And then there are numerous other reasons why we might not trust science. One is that facts are no longer always discernible. Technology can fool the senses undetected. Porn films can be made with the face of a celebrity pasted over an actor, so it looks like the celebrity is acting the role, not the porn star. The quality of fakery is excellent, and there's next to nothing the celebrity can do to prevent the production and distribution of such forgeries. Politicians and anyone else who comes under the media spotlight are not immune to such denigration. So what we see with our own eyes is harder to validate as objective truth. Science has delivered the means for humanity to destroy itself with nuclear weapons. Yes, it was scientists who did that. Many have apologized or expressed regret or shame. But are the scientists to blame for discoveries? Surely it is all of us who share the responsibility of deciding what to do with the knowledge that science brings. How could science itself be immoral? Surely it's the use science is put to, which is either immoral or moral. Science is being promoted by new atheists as a modern faith, a faith in competition with existing faiths. Some claim that scientists will become omniscient, solving all of the riddles of God or evolution, depending on your faith. The idea of science as a faith is at odds with all previous understanding of science back to Aristotle. Whatever the philosophical arguments about faith and science, many of us find no difficulty in having faith in God while using the methods and enjoying the fruits of science. But not everyone is so broad-minded. Scientists tell us that things are getting even better. Steven Pinker wrote a book called Enlightenment Now. Hans Rosling, a book called Factfulness. Matt Ridley, a book, The Rational Optimist. And many of us read them, but many can't see that and simply disbelieve them. As someone said, the moon landings could not have been faked because in the 1960s the technology of fakery had not advanced far enough to fool us, whereas the technology of moonshots had advanced far enough by then, if only just. Flat earthers just do not want the earth to be spherical for whatever reason. Anti-Semitics do not accept the historical record of the Holocaust because it elicitates sympathy for those they hate. If for any reason we don't want to believe science, we won't. The books listed here, and many more like them, tell an upbeat story of human progress and tolerance, but not everyone wants to hear that kind of thing. It is probably only in the past decade or two that science has become so unacceptable to so many. In the age of reasons, science had broad acceptance and appreciation. But now? Problem number 2. Science is up against worrying and wicked problems. What is a worrying problem? Well, worrying problems were defined by Oren Cass in an article in National Affairs magazine back in 2017. An example of a worrying problem would be worst case, that's alarmist scenario, climate change. There are 3 aspects to a worrying problem. Firstly, it's forecasted. It's not happening now. The main effects will be felt in the future. The second aspect, but any effects would be irreversible. There's no second chance. You need preventive action now. Third aspect, it's pervasive, meaning widespread across humanity. There's nowhere to run. And irreversible and pervasive means theoretically existential, certainly in the case of climate change. As Oren Cass says, these kinds of problems are tailor-made for worry because while the damage is only hypothetical, forecasted, it could be almost unlimited, irreversible and pervasive, And what worries you masters you with a feeling of helplessness. Or you deny the inconvenient truth with a vague feeling of hope that things will turn out okay. And that word forecasted is problematic. Claims of what will happen far off in the future can never be proved wrong. As Keynes said, in the long run, we're all dead. So you can make up anything you like about the far future. What's a wicked problem? Well, an example of a wicked problem would be income and wealth inequality. Definition from Wikipedia. A wicked problem is a problem that is difficult or impossible to solve because of incomplete, contradictory, and changing requirements that are often difficult to recognize. Where income and wealth inequality is an example of a social problem where there are dysfunctionalities within a complex system. So it is naturally resistant to resolution. Try and find a single cause for inequality. If you do, you end up with generalities like capitalism. And then an impossible question, how do you solve capitalism? More serious attempts to get to grips with the issue find multiple interdependent variables, and thus it becomes very difficult to find any kind of solution. And there are no experts that are accepted and trusted by all sides, so there are no accepted facts, or very few accepted facts. The use of the term wicked here means resistance to resolution rather than evil. Wicked problems are best understood in contrast to tame problems. Tame problems are those that can be defined, understood, and a consensus reached on a solution. Even some difficult problems can be described as tame, like the eradication of cholera, for example, where most people involved agree on the facts of what the problem is and how it should be resolved. Once the facts are established, it becomes an issue of resources, money and skills, and political will. For tame problems, the most important step is to get the facts. As Jack Welch, when he was CEO of General Electric, one of the most admired companies in the world at that time, said, "When everybody gets the same facts, they'll generally come to the same conclusion." But wicked problems, such as income and wealth inequality, do not have a set of accepted facts attached to them on which there is broad agreement. We tend to approach complex social problems through our existing subconscious value appraisals. So the logical trade-offs needed become affronts to our beliefs. And heaven forbid that we use the C word. In the absence of accepted facts that a diversity of minds can address, problem resolution is dominated by clashes of feelings. And the thinking that trade-offs and compromise require. Yes, the hated C word. Those get crowded out because whereas you can compromise on your thoughts, I'll accept this if you accept that, you don't compromise on your beliefs now, do you? Wicked problems are seen through the value systems of their beholders. So solutions can only come from what we feel, because there is no widely accepted version of the truth. Here's a wicked definition of a liberal. The answer is big government. Now, what was the problem? Or for conservatives, there's always a wicked lack of personal responsibility. It's rarely a systemic issue. Problem number 3, science as politics by other means. Clausewitz famously said, "War is the continuation of politics by other means." How about science? Can science be used to fight politics? Wicked problems, as we discussed on the previous slides, there's no widely accepted experts or facts. Science is used to bolster the competing sides. Take genetically modified organisms. Examples being seeds, the seeds of staple foods like wheat or rice that have been genetically altered so that they are more resistant to disease or less appealing to pests. The debate, no, not really a debate, the bad-tempered argument, no, that doesn't quite get it either. The fight to the death over whether these seeds should be allowed continues. And science is involved. It arms both sides. The two sides of the debate were described by Schulman in an article called Science Anxiety in the Hedgehog Review in 2016. So side number one bases its argument on ecology, on the complexity, interconnectedness and lack of predictability in ecologies. Because we can't know in advance exactly how the ecologies into which these seeds are sown will evolve. So these Frankenstein foods should not be used. The opposing team based their arguments on molecular genetics, talking about controlling the attributes of specific organisms for human benefit. All they're doing is altering the genetic makeup of molecules, something that evolution has been doing since life appeared on Earth. So these famine-avoiding crops should be used. From an ecology perspective, GMO, genetically modified organisms, are Frankenstein foods. From molecular genetics perspective, they are famine-avoiding foods. As the Schulman article puts it, the seemingly unitary conflict over the risks and benefits of genetically modified organisms is actually a conflict between broad disciplinary approaches and their conflicting ethical priorities, political valences, and even metaphysics. In simple terms, one branch of biology versus another. Another example from the social sciences, crime. This one's from a different article, Wicked Polarization, How Prosperity, Democracy and Experts Divided America by Ted Nordhaus and Michael Schellenberger, the Breakthrough Institute, 2013. So, they start with the premise we might agree that the crime rate has gone up or down, but disagree whether the cause is poverty, racism, the prohibition of drugs, the weakening of traditional moral values, or too few police officers. All of those arguments can be supported empirically, i.e. by different experts with different facts, similar to the GMO example above. Experts and their facts can be found from different disciplines with different viewpoints coming out of different value systems, even though, or especially because, they are looking at the same wicked problem, in this case, the crime rate. And these two articles hammer that home. As public interest in a question increases, the bodies of evidence available to support each of the contrasting position grows. The more clicks, the more expert witnesses are brought in to both sides. And these expert witnesses, their views are often boiled down to a limited number of characters on Twitter. There are no value-free, true-false answers to any of the wicked problems governments must deal with. That means the motivated reasoning from your value system is not totally correct. And the motivated reason from my value system is not totally correct. But that's difficult for our value systems to accept. To expect science to adjudicate normative questions only entrenches the rival positions. That follows. The more we invoke science, the more the other side will invoke their science. Facing up to this is very difficult for most of us who have been brought up to believe that science is neutral. and that objective facts settle arguments. The realization that science is just another front in the culture wars is dispiriting. It's particularly demoralizing when we come to what is perhaps the defining problem of our time and the subject of the next video lecture called climate change. But the problem is not that we are in a post-truth age, but rather that we have not learned to adapt to it. Thank you for watching. The next in the series, Understanding Ourselves Through Our Human Values, is the second of 3 lectures about the human value of science. It is called Climate Change and explores the question, what does science tell us about climate change? It can be found at www.conservatus.com, where there's reasoning that resonates. Conservatus, keep safe, intact, safe from danger, our human values.